Right. This time, let's take a look at going the other direction. I've got in my hands a function, and I would like to find a power series representation for it. Again, our go-to formula is the formula for the geometric series, which looks like this. This actually makes our job extremely easy because my formula here is already set up to behave or to be in the exact shape of the formula for the geometric series, how we usually write it up here, okay? So for a fixed x value, this is a geometric series. Or can be written as a geometric series, I should say. Pardon me. This can be written as a geometric series with A equal to 2 and R equal to X, right? R is equal to X. So for an X value, absolute value of X that's less than 1, our function would equal sum from n equals 0 to infinity of A times R to the n. Okay? That's a power series representation right there. We've already got our radius of convergence. That says it right here. R equals 1. And the interval of convergence is derived from writing this out as minus 1 is less than x is less than 1. So there's everything in the back. Now let's up the ante a little bit by not starting with something that's so obviously in the form of a geometric series, but the same attack applies. You just need to write it in this form. So let's take a look at this guy. I've got something sitting up in the numerator, which is totally fine. Anything that's up in the numerator can be the A. Down here, however, things do not look like 1 minus something, but I could write them that way. So in my denominator, I'm going to write the 1 first, and instead of adding 2x to it, I'm going to subtract a minus 2x. It's the exact same thing in the denominator, right? So using my color highlights here, here is the A, and here is the R. Okay, so for fixed x values, or I should say, that sounds kind of wrong with a plural right there when I'm saying it's fixed. So for a fixed x value, sounds a little bit better. Where my R happens to be between minus 1 and 1, right? So I need to have this happen if I'm going to write out any equation that looks like this. Any equation that looks like this is always accompanied by an inequality, okay? So if I want to write out the inequality, I'm going to have to say exactly what x values it's good for, okay? So keep that in mind in your work. Inequality always goes hand in hand with one of these power series representations. So for a fixed x value where, in this case, this is my R, right? I'm not going to write it. It's obviously my R. I've got it highlighted right there. So where my absolute value of R is less than 1, then my series or my function can be expressed as this series, sum from n equals 0 to infinity of a, which is my x squared, times r to the n, and my r is minus 2x to the n. Okay, so this is basically the whole problem right there. The only thing that's left is to maybe simplify this guy and use this to find the radius and interval of convergence. Okay, that's really all there is to it. Let's go ahead and simplify this guy right here. So I can just put the nth power on the 2 and collect my like powers of x, or collect my exponents with a like base, I should say. So I'm going to have a minus 2 to the n. I'll write it as an alternating sort of form, so it's sort of obvious where the sign comes from. The n is going on the minus 2 power. The n will also go on the x power. However, I have 2 more x's over here. Okay. And then let's work with this to find my radius of convergence. So this is obviously saying the same thing as 2 times the absolute value of x is less than 1. So it says the absolute value of x is less than 1/2. So my radius of convergence, r, is obviously equal to 1/2. And I can also find the interval of convergence by writing it like this. So the interval of convergence is minus 1/2 to 1/2. Okay. Just keep this in mind. That's all you have to do, is just write the algebra so it becomes to look like this, and then just write out what your geometric series says. This is when it converges for what common ratio. This is what it converges to.